The thing about compliance is it ratchets up, it never ratchets down.
Welcome, everyone, to a special episode of Continuous Delivery Office Hours with our founder, Paul Stovell. Today, we're going to look at this bottleneck that gets overlooked in conversations about AI and developer velocity, which is the organization's risk tolerance. Paul, thanks for joining me. Can you set the scene for me on this problem of velocity mismatch?
One of the interesting thought exercises is to think about if you took a really great engineering team, imagine like the best, most productive engineering team you can think of. And if you think to that team, it's probably not that you were so impressed that they were writing code really fast. You were probably really impressed with their ability to make changes that ultimately made their way to production that made the company more successful or created some kind of customer impact. That's often what I think about when I think of like high productivity software teams, right? If you take those people and you parachute them into a different environment, let's say a larger enterprise that's heavily regulated, compliance and so on, you just are not going to expect the same kind of output. So if you zoom out and we say, okay, these larger enterprises, mid-sized companies, what is it that fundamentally makes them slower to react, slower to move, slower to get changes into production? And we don't have to say that that's wrong, but what is the thing that makes them slower than, say, a smaller company or a smaller, more nimble team? I don't think it's the engineer's ability to write code quickly. I think what it is the risk tolerance of the organization for the volume of change. So it strikes me as maybe missing the problem to begin with when we think about in these larger organizations, larger teams, that we're going to get a productivity benefit by having AI help us generate changes faster, because we could already generate changes faster. We have talented programmers who can make a lot of change quickly. What we struggle with is the risk of those changes. And I'm not sure that increasing the volume of changes sort of makes up for the risk. I was thinking when I wrote that post about the self-driving car phenomenon, where when a human makes a mistake, we forgive humans because we're all human and we make mistakes. But the self-driving car, because it's a system, because it's a machine, it should be really predictable. So if it can have one accident, it must have a lot, and that's not acceptable. It can be eliminated. So I think what's almost going to happen is, like in physics, the equal and opposite reaction. For the increase in volume of change that will come, particularly in environments that are a little bit more risk averse, there's an equal and opposite compliance and risk reaction that happens to that, right? And I feel like they find their own equilibrium. So if you think, within a large organization, if we make 100 changes into production today, maybe tomorrow we start to make 200, but maybe production starts going down a lot more frequently. Then the risk and the compliance kicks in, and somehow we find ourselves back to 100 changes going to production. But now we have AI authoring some of them, but we didn't really get this sort of productivity benefit everyone's hoping for.
It's super interesting because we're talking a lot about developer velocity at the moment. There is a compliance velocity that maybe we're not talking about. And if we're going to increase one, we have to increase the other.
If we work back from how do we fundamentally increase the velocity of a software team within an organization that's not just a small team? Again, I don't think it's writing code faster. I think actually it probably has more to do with the risk assessment side. So, the fun thing about modern cars when you drive them is all the safety things that end up being built into it, they make you feel safer as you're driving. You don't actually need the machine to be doing the driving, but there's sort of a kickback effect where the work that's gone on to make the self-driving car safe to drive on the road has kind of helped the humans be more safe as well. I think there's something like that in the risk side where, in the sort of pre-AI days, let's say, and particularly in the pre-continuous delivery agile days, a lot of enterprises will have a change advisory board where we're looking at what's changing, what are the risks associated with the change, what mitigations do we have in place for the risk. And that's like a gauntlet that every change in the organization has to run through to make its way to production, right? But there's a reason. It's not because people were foolish in creating these things. It's because the risk and the downside of production being down is so much more harmful than the incremental benefit of the change that these things exist for. It strikes me that like machine intelligence would do a really good job of reasoning about the risks involved in a change, sometimes more so than thinking about what type of change needs to be made. And so I think in some ways more focus on reducing the risks involved in making change, whether it's humans authoring the changes or machines. That seems to me like it would go further to actually unblocking the velocity, right? What if I can deploy on a Friday and it's not a big deal because nothing too bad can happen? What if every change runs through a very consistent process, so the process is getting better over time across all of my applications rather than a bespoke thing for every application being done randomly in production? I think all those things kind of reduce the risk. That gives the organization more tolerance then for the occasional thing that goes wrong because it's much less frequent.
I like this. So this isn't about trying to scale up the compliance team to make them be able to handle this increase. It's about actually let's apply continuous compliance effectively. It's like, how do we actually make it so that these decisions can be made more smartly so that those decisions can keep up with that rate of change?
Yeah, let's use like a practical example. If you imagine, why do we do reviews on pull requests? There's a few positive benefits from it. We get some extra learning, we get some extra eyes on the code that can give us ideas on how to make things better. But fundamentally, it does slow down the speed at which you can make changes, right? And it creates a context shift and it sort of puts some work on someone else's queue. I don't know that we only enforce pull requests across the company because we think there's an incremental learning benefit that couldn't come about some other way, right? Because you could always read the code at the end of the week, right? On Friday, we read all the code changes. Or there's other ways you could approach the learning elements of it. I think the reason we do it at the pull request is because it creates a bit of a risk checkbox, right? It almost feels a bit cowboyish not to have a pull request review for every change that goes through, but it adds some slowdown to the process. Now, it seems to me that you could have AI reason about the risks of a lot of changes and say, well, this one looks very high risk. I think a human should review it. This one looks fairly low risk. And I think, the AI could approve that and let it go through, right? If I'm making a one-line CSS change, and the test coverage is decent, I don't think it needs a pull request review. We become more risk averse as a software team scales up, I think, and maybe that's something AI can help with.
And we apply blanket rules because it's either everything has to have a pull request or nothing does. There's nothing in between. What we're saying here is actually there's a decision to be made about whether a pull request is needed, whether it's useful. It does seem kind of funny that we're spending quite a lot of money on AI for developers. And so the thing that maybe was going to take them an hour, maybe they've done that in 10 minutes. Amazing. And now they wait 50 minutes for a pull request. So it still takes an hour.
Yeah.
So it's interesting that we've paid all this money and we're not getting anything from it.
Yeah. And maybe to give another example of like the equal and opposite reaction phenomenon that I think is coming here is one of the things you find, like as you go from a small software team of 2 or 3 people who are talking all the time, that small team builds up a lot of shared context of exactly the problems to be solved, how the user experience, because generally most software products are used by like one user, but they're built by many authors, but there's only one user at a time, going through the entire experience. One of the problems that we found as we grow the engineering organization is how do you create a cohesive experience when there's so many people touching so many different parts of the user experience? And you want autonomy, you want teams to be able to move quickly, you want them to become sort of masters of the area that they're working on without having to kind of get every change checked across the world. Now we're going to have all of our software engineers using AI to help author their changes. So Fred, the software engineer, is now this really highly productive software engineer who can make a lot of changes quickly. But Fred is doing it within the context of the AI tooling that he's personally using. That lacks even more context, right? Like Fred probably at least talks to some of the other humans on the team and has a bit of a shared understanding of the experience, but the AI really doesn't, right? And we're all talking to our own agents and getting changes authored in a central place. So I think one of the equal and opposite reactions becomes, okay, we're making a high volume of changes, but the user experiences are becoming way more disjointed. And this end-to-end story is not being told in a lot of the software that we're building. And the answer to that becomes centralize things more, bring it back, make it, it's not a risk problem, but it's like a how do you make things cohesive problem that we need to invest in next.
Yeah, that makes sense. We've seen this before when there was a big wave of team autonomy where people just said each team can choose whatever tools they want to use, whatever version control, whatever CI server, just go and pick the things that you're going to be most productive using. And what they found was after 6 months of doing that, it's very difficult to move between teams because you have to ditch your entire tech stack because this team is working in a different language, different version control, different CI system. And we kind of have that with our on-machine agents are highly fragmented. They don't have the same context. They don't have a shared understanding of what good looks like. And so that's a problem to solve.
How would you solve it?
A lot of the tools developers use are very collaborative. So once you hit commit, everything from then on is a tool that is shared by everyone.
It's a team tool, not an individual tool.
Yeah, so I think that team tool is what's missing. And it's not let's all have a markdown file that we share between our machines. That's like solving a part of the problem. But I think we need a team tool version of all of this.
Yeah, you could almost imagine a world where it doesn't make a lot of sense to have an agent or individuals using their own AI tooling to do a lot of the things they do on a daily basis. It probably makes sense to centralize those in team-based tools. You know, in an ideal world, well, the reason our software teams can't have like one SRE, in some ways it's really great when you only have one SRE because they don't have to take time to document things and, you know, but at some point that becomes a risk and a problem. So you end up with multiple SREs. That gives you the redundancy and the safety and everything. But then the sharing information becomes really hard. AI, I suppose, doesn't really have that problem. So you could definitely get to a place where our software is augmented by one AI SRE that sort of builds up a ton of context that no human ever could. In fact, you could do the same around risk and compliance, I'd imagine. So the human that is kind of looking at risk and compliance is augmented in some way with one single thing. You could probably do the same even around user experience, right? Like imagine, I was talking to our lead designer the other day, Laura, and she said one of the challenges is that we can all look at the same Figma, but we don't all have the same eyes. You or I may take the Figma mockup and do our best to replicate it in the software that we're building, but the margins might be off, the fonts are off, and we don't notice because we're developers, we're not designers. But you could have an AI designer that is looking at every change coming through and saying, does this still look good? You know, and if not, what goes on the pull request to send it back? But I think to me, those fall into that sort of similar category as the risk reduction, which is like, how do you prepare for that equal and opposite reaction? Because I'm thoroughly unconvinced that software is built on a volume of code change. Software tends to be built through the volume of like deep understanding of the problem, strong opinions about how the problem can be solved, where sometimes running really fast with code doesn't sort of masks that. It gets you away from it, but you never quite solve the real problems you're trying to solve well.
Yeah.
Whereas on the risk and the review side, I think it could be very valuable.
That makes sense. And I think that kind of speaks to, there was a study in the Dora report a couple of years back about user centricity. We're all used to the different levels of software delivery performance, you know, low, medium, high, elite, and they're kind of deploying more often and their products are becoming more successful as they can deploy more often, usually because they're trying to build those feedback loops. Did this thing work? But there was this class of team which was just user-centric, and they are just super close to understanding what the needs are of the user base. And it doesn't matter whether they're low, medium, high, or elite performance, because they don't need to fire as many arrows to hit the target. So if they're deploying half as often, but every arrow hits the target, that's better than someone who's like firing off an arrow every second, but they're just scattering across the field.
Yeah.
So that makes sense. For the compliance picture, it's having something that can decide what level of care and attention is needed, like depending on, I suppose, different factors to do with the software and the team and past events that have happened, which is usually how change approval boards get created, right? It's like past trauma.
Yeah, that's right. So there's this concept I've been trying to get to take on, and I've never kind of made it land, but it's this idea of product velocity, right? So if you imagine there's a bullseye, and at the center of the bullseye is like absolutely perfect product market fit ahead of everyone else in the market, you know, the very best thing that your customers could ever want. And none of us at any point in time are in that bullseye, right? None of us have a product that's quite in that bullseye. We're always somewhere around it. And so what we're trying to do is there's a vector. There's like, how far do we have to go? Like, what's our speed to get to that bullseye? How quickly are we making progress on that? And then are we going in the right direction, right? Or are we drifting away from the center of the bullseye? So direction and magnitude. In some ways, one can make up for the other. So going in a slightly better direction, right? Being slightly closer to the customer, being slightly more thoughtful about what you build can make up for a lot of lack of speed, even in a high risk environment where the changes are difficult to make happen. And the flip side too, a lot of speed can make up for going in the wrong direction, particularly because you can course correct. And you could even make the argument that maybe betting on speed tends to work better than betting on direction. But betting on speed can also run you really fast in the wrong direction. And particularly in risk averse environments, that's going to make that equal and opposite reaction happen much faster, right? I saw this. What was that thing a few weeks ago of like Amazon saying, hey, all these AI changes, AI authored changes we're making are bringing production down and making our systems unstable. And it only takes a few of that kind of thing. And you extrapolate and say, well, if we expect this is going to go from 10x to 100x, because we're all meant to believe that as far as AI goes, well, we're going to have the same thing on the risk side, right? If production goes down once a month today, what does that look like when the volume of change increases?
And this is going to get quite serious when we start hitting vital services like finance and energy and all of these sectors where the tolerance for things breaking and being fixed and breaking and being fixed is super low. Like, how many times will I tolerate money leaving my bank but not arriving in the other bank? And then eventually it might get reconciled and fixed. But how often will I tolerate that stress of wondering where my money is?
Yeah, I think that's totally right. I remember when like continuous delivery came along, and you would see to teams that really embraced it, you saw this transformational effect where what would happen was if a team was in a habit of shipping software into the hands of end users once a month or something, what would tend to happen is they would ship the change, they'd go to the customers and they say, hey, the new version's in production now, have a look. And on the customer's mind is, I generally like the software, but it's got these 3 bugs in it. They're really critical. I really hope that's in this release. So my problem, my pain has gone away. And otherwise, I'm not expecting too much to change. And then, of course, they load the new thing, and it's a whole month of work that you're now shipping in front of them. So there's a new feature here. The navigation's changed a little bit. And you fix one of the bugs, but you introduced another one, and there's a couple that still aren't fixed. And to the customer, it becomes a thing that erodes trust in the software team because it's this sense of like, I'm not even going to spend too much time engaging with this because the feedback I'm providing isn't really being listened to. And whereas like what would happen in a continuous delivery environment is the customer can report something because in the customer's mind in that previous example too, they've been waiting a month for the change and you've only half delivered, right? And then you move to a continuous delivery model where, every week, ideally more frequently, we're shipping changes in and we're putting them in the hands of customers. That bug that they reported on Tuesday is fixed by Thursday or, the following week. And it's not a huge volume of change where they have to, I don't know if you've ever done this thing, you do things on social media and you get all these positive comments and then you get the one negative one and it sticks out, right? Now think about like organizational communication, a whole bunch of positive feedback about the changes your team has worked really hard on for the last month, and that one negative comment about the work you did, which one stands out, which one resonates, right? And that kind of ends up working in both directions. So you get these like real communication problems and trust problems that build up, which gets solved by the sort of increase in frequency of delivery. But it has to be done really tastefully, right? That no one ever said, let's do continuous delivery and it's okay to ship bad stuff that doesn't solve customers' problems. But don't worry, just ship more and that will make up for it. There's definitely an area of experimentation and learning along the way, but our tolerance for the quality of what we're doing never went down. The assumption would be if I'm shipping twice as much, twice as quickly, the quality should be at least as good, if not better, but certainly not worse.
Yeah, that's what makes it continuous, is that you can declare every day that your software is releasable, it's good quality, which is kind of the counterintuitive insight that came out of the DORA research when it first came out. It was these teams that are deploying more often also seem to be the kind of teams that have fewer quality issues.
Yeah, because like work finds a way to get done in any organization. It's a question of like, is it happening through the default path? And the default path is the easiest way to get the work done? Or does most of the work happen through an indirect way? If the default easiest way to ship software is also the most compliant way, the safest way, the most low risk way, but the fastest way too, like we're trying to maximize for all of those things, not any one of them, then you're much more likely to be successful than if people are trying to find workarounds. I mean, what we can't do is we can't go backwards either. We can't get to a world where 10 years ago, if we were giving junior devs direct access to do stuff in production, we all would have laughed at how dangerous that was. We don't want to give the junior devs an AI that has access to production. The governance part becomes even more important, but in some ways maybe less obvious because there is this sort of AI intermediary that's going on that's still taking commands from a person.
Yes, and I think that's probably where all of these stories about people's production databases getting deleted come from, is people moving backwards to open access to do things that really, why did anyone have access to do that in the first place? I don't think I've logged into a production database for over a decade. It's just not how you do things anymore.
Yeah, in an ideal world, that's right.
So the deployment pipeline is this fastest way and the correct way of getting software to production. And all of the checks should be part of that. And that includes all of the technical checks, all of the validation that we do, automated tests. If there's peer review needed, that's part of that process. We also want it to include the compliance concerns and the security concerns. We don't want those to be done out of band. The signal of you getting this right is going to be when you do have a critical issue, does it go through that same pipeline, or do you have a sneaky like expedite lane that gets that change out there quickly?
Yeah, is there the equivalent of the email the CEO workaround to the process when things actually are really important? I think that's right, and I think that's where you talked about like the one size fits all CD pipelines that I think we have today. I think that's where that's particularly challenging. I got to pick on an example actually. The one that bothers me the most is automated integration and like user acceptance testing, right? Like user experience automation, that sort of thing. Those test suites start small. Maybe it takes a few minutes to quickly generate, like run the UI, click some things and shut it down. Over time, because we're generally trained that testing is good and not testing is bad, there's a natural momentum that the number of tests increases in a good organization, right? If you were the maniac developer that joined the team and was just deleting tests because you didn't think they added value, like the team wouldn't respond very well to that, right? There'd be this sense of you're doing something dangerous. But because there isn't that pressure to remove tests, what happens is the test suite gets bigger and bigger, longer and longer. And you get into this ridiculous situation where we're running 3 hours of automated user acceptance testing for something that doesn't even affect the user experience. Because a human could look at the change and say, I know that there is no way that this would change the way the UI works. You can't say that for all changes, but for this specific change, you could reason about it and say, this is a low risk thing. But the systems can't really reason about it in the same way. And so it runs through the same 3-hour test. And now maybe you've got a team of 100 engineers and all the builds take 3 hours to get through that testing cycle, and it's okay, you're living with it. Now increase the volume of changes being generated. And what does that look like? What does it look like in terms of the compute costs to run all those tests that are running in a pointless way anyway? And what does it cost when there's more and more things going wrong in production because of the volume of change, and we're having to work around because we can't wait for 3 hours to get production back online, right? And this is where there's something really powerful about thinking about how does AI apply not to the world of change generation, but to the world of making the pipeline the easiest, fastest, most compliant way to get changes into production and keep production stable. Rather than having AI to generate tests for me, I'd love AI to think about, given this change, what test suites are worth running and which ones are not.
Yeah, that makes sense. If I updated a README because I thought I could improve the prose of a description of how to run the system locally,
Yeah.
do I want to run 3 hours of tests on that? And I wonder, there's a chance if your organization has manual validation steps that this is going to look like a new software version and people will spend time manually testing it as well.
Right. Because you changed something that never actually changed the deployed artifact.
Yeah.
And even just you think about the sheer amount of money that must get wasted running long-running builds that just don't need to be run for batches of tests that don't make sense.
That's quite scary, actually.
But it comes back to like, why do we have these large test suites? Because we're kind of risk averse, aren't we? Particularly on larger software teams, established things. Startups don't have like huge test suites. They haven't written them yet. They don't have huge volumes of user testing because they can't afford to run the compute for it, or they can't afford to write them, or for whatever other reason they haven't got to them. But 10 years later, they have a whole bunch of these things they've collected and they keep them because it's good to keep them, isn't it? but it slows us down sometimes.
That makes sense. And I suppose when you're thinking about an organization that has scaled in terms of the size of the organization, but also the success of their software, it kind of makes sense, right? Because now when they break something, it's not 100 people that they've upset, it's thousands of people that they've upset, or maybe even millions of people that they've upset.
Yeah, the sort of how do we reduce risk instinct is right, like particularly as the customer base grows and the importance of what we're building grows. And that's why these organizations, I wouldn't say that if you work at a highly regulated industry or something, if you took the world's most productive software engineer from a startup and put them into that environment, we know that they're going to ship less changes to production than they would in the startup environment. And that's not necessarily wrong. But I think what is wrong is then to bet that within environments like that, we will see a massive increase in productivity by just focusing on the volume of change creation, which I don't think was ever the problem to begin with, without focusing at least equally on the volume of risk reduction work that we can do that gets it out of the way, right? Pull requests, I think, go a really long way to removing the need for change advisory boards and the complexity of that. Not all the time, but they can have a meaningful impact on the need for changes to go through that. But there's a lot of ways, I think, to push that down the stack.
And this is the logical extension of DevOps. So we started off with DevOps, which was what if the developers and the ops team kind of sat together a little bit and shared some problems and improved that collaboration. And then we had the era where everyone was adding another thing in between, DevSecOps or DevFinOps or FinOps or whatever, all these different combinations. The logical conclusion of all of that is that we go back to what Dave Farley said in the continuous delivery book, which is all of the steps that you need to get that software to production are part of it. And if that's dev, it's ops, it's security, it's compliance. There's like all those different perspectives are part of that wider thing.
They sort of are, but what comes to mind is there's a slight difference. So compliance is one of these functions where no company ever had happier customers or got more successful because it overinvested in compliance. There's like the right amount of investment to make in compliance, but then overinvesting in it in a lot of ways can slow you down, right? And take away from the things that customers do want. You know, if I've got a bank that I use for my personal banking, of course I don't want it to lose my money. And of course I don't want my details to get leaked. And so I would expect them to be investing a lot in security, risk, and compliance. But I also want the mobile experience to be a little bit better than the thing that they released in 2005 and haven't really maintained. That's the thing that's going to help me choose which bank to go with next time. You can't over-index on the compliance thing in the way that you actually can for a lot of other things. You can over-index on the size of the team, and those things will sort of help you make better software to a degree. But the compliance side, there's like a minimum. But what happens is when we're not careful, that thing keeps ratcheting up, right? So, because here's what could happen. You could imagine a world where we all get carried away with changes, like the generation of changes with AI. So suddenly we're making 20 changes a day when we used to make one, per engineer or something. Now our production's going down way more often. If we used to have one data leak a year, now we've got 20, right? There's something that's starting to go wrong there. The thing about compliance is it ratchets up, it never ratchets down. So once a requirement comes in, particularly once it becomes so top of mind for regulators and other people, it gets its way in there, and removing it is almost impossible. It's a one-way ratchet on compliance. Whereas velocity is not. Velocity can go up and down as the team changes, but the compliance only ratchets up. So the risk becomes we all get carried away. We all start throwing agents in, doing stuff in production. The ratchet of compliance and risk increases. And then we all decide, actually, there's a more balanced approach here. Humans augmented with software agents and where they make sense and where they don't. But that is like, it's ratcheted up already. Even just the human team now has to work through, the team that's not using AI at all has to work through this sort of ratcheted up risk and compliance thing that's designed under that to protect those risks. Does that make sense?
It does, yeah. I can imagine teams where there is one developer and then 4 developers managing all of the audit requirements for that one developer. On the compliance teams where it was a small team, you act as an enabling force. You're trying to help other people be compliant. When the team reaches a certain size, you kind of become the people who police the compliance, and you start creating a load of tasks and activities because you have all of these people in your compliance team. Good compliance is like how do I help you be compliant? That would be the ideal kind of compliance.
When humans make mistakes, we are pretty good sometimes at isolating and saying, Fred dropped the production database. There's a systematic problem we can look at, which is why did Fred have production access and how did it happen? And there's probably some kind of training that we can do with Fred. But we can generally, like sometimes the best thing to do is sort of local solution to a local problem, right? So the local problem here is Fred on this team had access to this database and shouldn't have, and we'll fix that and learn from it. But sometimes we take the global solution to the local problem, right? The global solution becomes like, no, the company's compliance regime is now no one gets any access to production. And it kind of works, but it kind of doesn't, and it causes all kinds of problems. But sometimes, if we're not responsible enough, it goes even higher than that, right? It becomes the European Union or somebody that introduces this regulation that we're now, because a handful of companies were misusing cookies, all of us have to click the yes cookie banner thing every time we visit a website, right? I think there's things like that already exist in highly regulated industries where software teams weren't careful about how changes happened. And so now everyone has to comply with this thing. And I just see it getting worse if the volume of change is going up, but the volume of risk is not going down.
Yeah, and I think that's the thing. You invite that control if you are not being responsible in the first place, right? It's a little bit like there's debates around AI at the moment. Should it be regulated? Now, if the AI companies were being responsible, it would not invite that regulation. I think that's the interesting piece about it. And it's the same with self-driving cars, anything new, really. It's like introduce a new idea responsibly, regulators aren't interested. They don't see a need to regulate it. So I think that's the challenge that these teams face is how are they going to bring AI in and use it in a way that doesn't invite regulation?
And it can be a downward spiral where what happens is you say, our team doesn't feel as productive as we wish it was. Let's use AI to help us make changes faster. In doing so, we cause more destabilization in production. We cause some data leaks, things that we were probably doing before, but we were doing them at a lower rate. But now the multiplier is up. We're doing those things more often. The one-way ratchet of compliance and risk kicks in. Even if we go back to our old practices, we now kind of have these extra tests we have to do or extra checks we have to do or something. And then what we say is, gosh, we feel really unproductive. If only we invest more in generating more volume of changes, right? And we're sort of back to the same thing, but one of those ratchets kind of only goes in one way. If you're raising a child or something, you want them to be more responsible. And one of the things you're sort of looking for is for them to start to act in a way that seems more responsible and takes responsibility for the thing. And that then opens up a lot more trust. I can trust you to do this thing because you've come this far. The way to avoid the regulator trap is to sort of be responsible for that stuff to begin with. But I think we're so excited because software developers have always been scarce, right? We never have enough software developers. We've always got bigger ambition for the software we've got that we're trying to build than we have people that can build it. So I completely see the excitement that we might be able to generate software faster. But in most environments, I don't think that's actually ever been the limiting factor. Most engineers can write code on their weekends and hours, their weekend hours, and put them into production really quickly at home, and they struggle to do it at work the next day. And it's not because the tooling they use is stopping them. It's because of the risk and compliance aspects that we got to find some way to at least automate if we can't ratchet them down.
We're looking at AI potentially increasing the rate at which we can change the system, but it's going to depend on us being able to balance that with the other steps involved in getting that software to production. Some of the solution to that could be that we create smarter pipelines that can make decisions about how much of those validation steps need to happen at each step along the way. Sounds like there's probably a big collaboration opportunity with those internal regulators that we might have in our organization so that we can make sure that the way we're working is sensible. And we want to make sure that there's this interesting trust piece in the middle of it where if we're frequently making mistakes, we're inviting this one-way ratchet problem to occur.
Yeah.
What do you think people should do next?
I think if your manager or VP or somebody has an initiative around AI productivity, as is common in a lot of companies right now, because we know that the risk compliance will find equilibrium with the volume of change, it would be to start earlier on that premise, right? So if the CTO is saying, everybody, we need to increase productivity, everybody's got to adopt AI to do things, right? And if what that translates into is every software engineer is learning how to use AI to make more changes faster, that is going to rapidly accelerate the risk and compliance ratcheting that will happen. But if half of them can kind of say, yeah, let's look at ways to make changes faster, and if the other half are saying, and let's look at ways to make them safer, more compliant, more less risk with AI, better cohesion around the changes, end-to-end stories, find ways to do that. That feels like it's going to be the responsible way to roll it out, and probably differentiates you too, because in some ways those things are always like at some point everybody will get tired of the new tool that helps us write code faster. But those things that sort of focus on risk is probably a good way to build a career around eliminating those things, because they tend to be more beneficial over time, I think.
Yeah, I think developers who have gone outside of just writing code and have dealt with those other concerns have always been the ones that end up becoming the sought after folks. We've always seen that.
Yeah, because the foundation of everything we do is based on trust, right? So just the junior dev making changes in production, causing things to go down, is not conducive to creating trust with the customer, and neither is the AI agent doing those things. And when the whole engineering team is focused on that path and not the how do we keep production up and robust path, we sort of invite a real loss of trust in customers. And I think engineers who've been around long enough understand how important that trust is and how quickly it's lost as well.
Absolutely. Well, a big thank you, Paul, for joining us today. The takeaway, I think, is that compliance is a one-way ratchet. And if AI just makes you ship faster without making you ship safer, you're only tightening it. So subscribe for more continuous delivery office hours. We'll probably talk more about the impact AI is having on our industry and what we can do to avoid the pitfalls. And we'll see you next time.